core cards, fractional playing cards. I'll go through some of the attributes of them. Inside the deck here, right on top, there's 2 direction cards, instructional cards. Then there's 16 blank cards. These are little whiteboards, so you could hand them out to your class and ask them a question. 3x plus 5x. They could just write down 8x, hold it up, and then just wipe it off and keep using it as a whiteboard. That's with a whiteboard eraser. If they actually invent a new game, for trig identities, or then they use a Sharpie and then it won't erase. So there's 16 blanks. We get to the 4 suits: science, technology, engineering, math. And there's 9 in every suit. So you can play all sorts of games, design your own games, work with the fraction, the decimal, percent, and then a reduced fraction in the other corner, so 4/8 versus a half, and then they could all put it together with the graphic. So those are the fractional playing cards, the core cards. I'm just going to show you some actual assignments that I give the kids. I call these reason cards. So here's a fractional sheet. I'm going to start here, and something plus something equals a half. I'll start out with, say, a half and a 0. So that statement holds true. Half plus 0 equals a half. Then going down, oh, that's not going to work. Because a half plus something equals 3/8. So this is going to have to be less than that. So let me move that one around. I'll put that half there. Move that around. Let me try maybe 1/8 and 3/8 gives me a half this way. Then 1/8 and a quarter gives me 3/8 that way. 3/8 and a half, 3/8 and 4/8 give me 7/8 that way. And there's a solution. There are multiple solutions, but I have 4 equations. This one, that one, that one. I could add a 5th by putting a multiplication sign in here and going 1/8 times 1/2 to get 1/16 down here. I really like these a lot because of the manipulatives and because of the multiple solutions. I actually sometimes create them where they don't work. Like have this, add up to, I don't know, 2. So the maximum value in one of these would be 1, then the 7/8, so you couldn't have a 2. And then ones that don't work, the kids have to write a paragraph why it doesn't work. There's another one. This is an algebra review, fractional algebra. Something x plus something x equals a half x. So I'll start just by randomly putting some things in there. I'll do 1/8 x plus 3/8 x equals 4/8 x, so that works. Then down here I have 1/8 x times something to equal 1/16 x squared. So if I place a half in there, that'll give me 1/16 x squared because this is multiplication. And then 3/8 plus 5/8 x will give me 8/8 x, so that one works. 5/8 and a half is 9/8, that works. We've actually done this one before. And then, it's really quite a bit of problem solving, and it's really nice with the manipulatives. These are the same reason cards for algebra. I'm not using my core cards for placements here. I'm trying to solve this on my own. Pick any value times x plus something equals 17. Infinite series of solutions, but once I constrain it, I want it to work. This equation, this equation, this equation, this equation, all the equations to be true. So let me start by saying 2x plus 5 equals 17. I solve that. X would have to be equal to 6. So x is equal to 6. So that means 2x times something has to equal -6. So this would have to be a -3. That could be -6 this way. 5 plus something has to equal 13. That would have to be 8. But then 8, if this is a plus here, 8 and -3 is not 6. No. Let me change this. Let me try it. 3 here now. 3x plus 5 equals 17. So that would put x equal to 4. right? So now x is equal to 4. 12 and 5, 17. 12 times, so this is 12 times what? 12x to get negative 24. This would have to be a negative 2. And this would have to be a 2. So let's see if this works. I have 3x times 2x is 6x squared. 3x plus 5, when x equals 4, 12, 5 is 17. 12 times negative 2, 12 times negative 2, negative 24, and 4 is in here for negative 24. That one works. 5 and 8, that must have been a plus. 5 plus 8 equals 13. So it's a lot more than solving equations.